Here we're going to look at how do we evaluate function notation given a graph. So first of all, just given the graph, how do we know whether or not it's a function? And that's going to come down to the vertical line test. So the vertical line test tells us for any vertical line that we draw, we should only be crossing our function at most once. If we're crossing in two spots, what that tells me is that for that input, we have too many outputs. So we should only be crossing once. Crossing 0 times is okay. We can have an output that does not exist. Totally fine. We just can't have more than one. So this function right here, because it passes that vertical line test, yes, it is a function. Let's say we want to find h of 2. So again, it's giving us the input, so it's giving us x, and I want to find the output. So I'm going to go to x equals 2, and then I want to find the matching y coordinate. So on our function, we have the coordinate 2, 1, and this function notation is asking for that output, which would be positive 1. Then for h of negative 4, again, it's telling me x is equal to negative 4. What's our function output? So if I go to x equals negative 4, I can find this coordinate negative 4, negative 5. And so for our function output, we want that y coordinate, which we just found is negative 5. If we wanted to solve h of x is equal to negative 5, so with this case, it's giving us the y coordinate. And the easiest way to go about this, I think, is drawing a horizontal line. So if we draw a horizontal line at y equals negative 5, then what we can do is see all of the intersection points. So if I do that, I can see we have two intersection points. One's occurring at negative 4, and the other is occurring at 0. So solving h of x equals negative 5 is going to result in two solutions, x equals negative 4 and x equals 0. So if we wanted to solve h of x equals negative 3, we would do the same routine. So I'd go up to positive 3 and draw a horizontal line and see where we intersect, which we're going to have one intersection, which is occurring at x equals positive 3. So with that one, we'll just have one solution, x equals 3. So you might have one solution, two, you could have 100 solutions, a lot more possibilities there. Finding the zeros of the function, I wanted to go over this terminology because it comes up quite a bit. And really this is just asking for where is our output equal to 0. So where is h of x equal to 0? So this is going to result in us drawing that horizontal line along the x-axis. So zeros occur along the x-axis, and then we go looking for our intersection points. Now these aren't pretty nice whole numbers, so we're just going to estimate here. So let's see, we'll have x equals, and how about 1.8-ish, 4.2-ish, and 5.8-ish. If those were a little different, if you tried this on your own, totally fine. We're just estimating as best we can with the information we have. For finding the y-intercept, this we go to the y-axis and look for where do we intersect with the y-axis, which is happening down at negative 5. So our y-intercept would be the coordinate x is 0, output is negative 5. And then our last piece with domain and range. What we'll have here is for domain, we're starting at x equals negative 5 with an open circle, and then we continue to be defined at positive 6. So we'll use for domain parentheses at negative 5 to show we're not including it, go up to positive 6 with square brackets. Then for range, actually this is a good graph to show. Domain, when we have these starting and ending points, domain typically uses those. Range is not restricted to that. Our function can go below those points, it can go above those points. So for domain, you could rely on those endpoints, but for range, you need to be a little more careful. So for range here, what I'm going to do is, again, starting at the bottom, I can see, okay, we're starting at negative 5 is where my function starts to be defined. And then we continue on to positive 3, where we're still defined 2. So where that endpoint was at positive 1 is what I was trying to say. We actually go beyond that point. Something else to keep in mind is I see this open circle at negative 3, but we're defined elsewhere at negative 3, so we're okay there. But say those were all open circles, that would make this gap at negative 3. So we'd actually have 2 intervals saying like we're going to negative 3 and then we're going beyond negative 3. So for our range, we're going to go from negative 5 to positive 3, and we're including both endpoints. And that's how we work with our graph with functions.